Hello, I've had a question about Unit 1 in Lesson 4. I'm looking at number 36. So it says a baseball player makes perfect contact with the ball, striking at a 45-degree angle. So the ball is going to travel 45-degree angle above the horizontal. It's 1.3 meters above the ground, so about waist height. And it just clears a fence or a wall over here. Here's my wall. It's not really clearing it. People out there that are a little OCD like myself. So there we go. And it was 130 meters away. With what velocity? So we're looking for an initial velocity. How hard did it have to be struck, or how fast did it have to leave the bat? So again, I'm going to list my information. So I do know my horizontal displacement. That's 130 meters according to my picture, right? My launch velocity, I don't know it, but it's the magnitude of my velocity cos 45. That's meters per second to the right. So I know almost all of that. And time I do not know. So that is definitely an unknown. So I have two unknowns here. I have the velocities an unknown, times an unknown. So I'm going to have to go to my vertical and see if I have any more information. So vertical, my delta D, I know that's going to be the difference between 3 and 1.3, so 1.7 meters up. I know my acceleration due to gravity. It's 10 meters per second squared down. And what else? I don't know how long it took for the ball to go up that high. And I do not know the launch velocity, so V vertical is also unknown. So in both cases, I have two unknowns. So this is one of those, what I'll call your hardest question I can kind of throw at you here. Two equations, two unknowns, so we're going to have to do a substitution. So I'm going to move back to my horizontal information and go d equals vt. And I have a distance of 130. Velocity is the magnitude of v cos 45 times time. I'm then going to take a look at my vertical equation. Delta d equals v1t plus 1/2 at squared. And what I want to do, I want to kind of look at this and figure out, well, what substitution, which one do I want to substitute here? There's really no right or wrong answer. It's whatever you're more comfortable with. So in this case, I'm going to choose to solve this equation up here for time. And the reason for that is because I want to find velocity. So rather than doing it in two steps, so I'm going to solve this. So my time is 130 divided by the magnitude of velocity cos 45 seconds. So I'm going to take that answer and I'm going to substitute it into the equation down below. All right, so I'm going to go up as positive. That means down is negative, so my acceleration will be negative. So that means 1.7 must equal the magnitude of my velocity. So that's the magnitude of v sine 45. My time is 130 over the magnitude of v cos 45 plus 1/2 times negative 10 times 130 over the magnitude of v cos 45, and that's all squared. So it does get a little bit more challenging algebraically, but what you'll find in this case is that the velocities are going to cancel out, and my sine 45 cos 45, I can rewrite that as tan 45. So it's 130 times tan 45, and some of you will be saying, well, tan 45 is just equal to 1. So that disappears as well. Now on this one, you got to be careful here when you do the calculation. Half of 10 is 5. Now we're going to have 130 squared divided by, and that square has to get distributed in. All right. So I'm going to do a bit of rearranging here. So at this point, I'm going to subtract 130 from both sides. So when I do that, move my 130 to the other side. Oops. I get negative 128.3 equals And I'm going to multiply that -5 with the 130 squared. So I get negative 84,500, and that's over b squared. I'm not going to multiply or determine the cos squared 45 right now because that's a decimal. I don't want to write them all out. So algebraically, I'm going to multiply both sides by v squared and divide by 128. So hopefully by grade 12, you're comfortable with just doing a bit of a switch here with those two values. It's negative 128.3 cos squared 45. So I'm just rearranging the equation, isolating my v value. Now I'm just going to calculate this all in one step, save me putting it into the calculator. So 84,500 divided by the 128.3 times, and just be careful when you're entering in cos 45 squared, and take the square root of my answer. Oops. And when I plug that in, I get 36.3 meters per second. So that's the launch velocity, and it doesn't tell you to switch it, but just to give you a feel for the bat, or the velocity it leaves the bat. If we multiply that by 3.6, it means it's going to leave the bat at about 130.7 kilometers an hour. All right, just to put it in perspective. So anyway, therefore, the ball will need to be launched at 36.3 meters per second. If you have any questions with that, let me know, and I'll try to clarify them. Good luck.